Hey guys, this is going to be a video on the repair of a battery for a Inmotion V3 electric unicycle. So I got this from a auction, and apparently this thing is brand new. So repairing the repairing the battery is the first thing to do. And so I don't know if this thing is actually working or not. So I'm going to first try to do a quick jump of this battery just to see if this thing powers up and stands up or not. So let's take a quick look at this battery. So obviously lithium battery pack. There are 20 cells in series, one in parallel. So there's 20 batteries in this thing. So I'm not sure if this thing, if this thing is just filled with cheap batteries and that's why it goes bad, or if this thing has a small drain in it. So if you leave this thing over winter without charging it, this thing might discharge enough. And if this thing discharges enough to go below a threshold voltage, then the BMS will not charge it. So it's kind of a protectionary type thing. Some BMSs do that. So if it's an over voltage, it will actually power down the battery and kill it for safety reasons, or if it's under voltage, then also it won't charge it as well. So I'm not sure exactly how these things go bad, but for sure, when you have 20 cells like this in series, if one of these cells is bad, this whole pack is bad. So when choosing batteries to repair this, which I'm going to do, I'm going to have to make sure that every one of those batteries is 100% identical, has the same capacity, and also has the same internal resistance as well. So this is going to be a very, very precise build, and that's probably why these things go bad and hard to repair. But anyways, let's start from the beginning. So the first thing I want to do is, as I don't know if this thing works or not, I'm just going to put 60 volts across this from battery 1 to battery 20, and let's just see if this thing powers up. So I'll just go do that now. Okay, so I just soldered some leads here into plus and minus, and I'm getting 18 volts out of it, which is from the charge that I tried, but it didn't go well. So for sure these batteries are bad. But anyways, let's just see if we what will happen. There's a chance this probably won't work, because the BMS will shut down at the first sign of trouble. So even now the BMS is probably shut down, and it probably won't do anything. But anyway, let's just try. Let's just see if something happens. I don't think the battery will blow up, but hey, you never know. Okay, and so this is plus. Yeah, okay, let's go. All right. So I think you just touch this. I don't know if this is going to go racing off or. Yes? No? No. Nope. Yeah, I don't think it would work anyways, because that battery pack, the BMS will shut down even if one cell is low. It will definitely shut down, and I think it also won't reset. If it fixes itself, it'll be shut down forever. Yeah, there's more chances of this not working than working. So anyways, okay, that's fine. Okay, so these are the batteries that I've salvaged that I'm going to be picking to put into this pack. So using my brand new Lito Kala Li 500 lithium battery tester, I'm able to now test batteries and determine what their internal resistance is. So not just capacity, which I could test before manually, this will actually give you capacity and it'll give you internal resistance. And so that way you can match up batteries in groups that will have the same internal resistance. So basically that means that you want to choose batteries that have the same internal resistance, such that when they discharge or charge up, that they don't unbalance themselves, right? They can stay closer within balance. So these measure from about 50 milliohms to around 65 milliohms. So these are plus and minus, let's say 10 milliohms difference. This is my first time doing this, so I can check after I do a full charge and discharge cycle to make sure, actually to observe how out of balance the individual cells become. So I'm hoping that now that they're more matched, that this is going to be a more robust, so that it'll be able to, the BMS will be able to charge up higher and to discharge more evenly, so you get more performance out of your battery pack. So I'm going to go ahead and remove these ones. These are mostly crap, but there's a couple that are still good, so I'll check to see if any of these are salvageable and just save those for another project, and then fill these up, weld them together, and then start putting it together. Alright, so I finished up building up the battery pack, but just for curiosity, I thought I would just test the couple of salvaged cells from this old battery pack to see what the capacity was. And interestingly enough, the good batteries are measuring in at 1.8 amp hours. So these are not top of the line capacity batteries that they're putting in this product. They're actually middle of the road. As compared to the ones that I'm putting in, which are about 2200 or 2.2 amp hour. So just by using better quality batteries, I'll be increasing the capacity of this battery pack by about 20%. But yeah, it's worth noting that the old ones are definitely not top quality. So you're paying large money for this consumer product, and they're not even bothering to use the best batteries in it. so after putting the thing together and measuring plus and minus, you can see we have battery voltage here, but when we check it at the BMS output, we're getting nothing. So if I remember correctly, so there's a reset button here, and if I remember correctly, the on the last one that I did, I think I pressed that button, so it was working. I recharged the battery as they were asleep, and then when I pressed it, it actually stopped working. All right, it was kind of like an opposite reset button. So I'm not sure what happened. I can't remember what happened, but I remember that after I put that one together, it actually started working. So when I buttoned this up, I put the leads on. The only thing I can do is maybe release the balance leads and put them on again. So I started putting from 0 and went up. So maybe I'll just try this one more time, and we'll just kind of unplug this one, and maybe we'll just try to plug these ones in a different order. Maybe that was, I can't remember what I did in that first case because it probably didn't come back. So let's just take these all out. Yeah, I can also check to make sure all these balance wires are soldered in, but I did it with a microscope. It should be okay. Okay, so we'll start with what's the highest one here? Is this B20? Okay, we'll start with this one. So same deal. Obviously, nothing registering. Oh, hold on. So this reads 39 volts. How about that? Okay, we'll start plugging the wires in. Plug that one in. 79 volts. Plug that one in. 79 volts. I don't know, plug this one in. It's 39 volts. And the last one with the ground. .39 volts. Okay. I don't know what I did, but it's working. 39 volts. Okay, there you go. All right. 39 volts. Good. Okay, so I didn't have to press that reset button. Just unplugging the balance wires and plugging them in again helped. Now this is a reset button. Some BMSs do have those push button resets, so you don't have to unplug the balance wires. But you know, there is a hole here in the case, I'm assuming, so you can access that reset button. Anyways, looks good. Wow. All right. No, there you go. All right. So just unplug and replug the balance wires. Fixes the problem. All right. So let's button this all together. Anyways, let's do that now. But anyways, just before we do, let's just double check that we're still good here. 79. All right. All right. So I'm going to just screw all this together, and then we'll go back to the wheel, and then we'll plug it in. without turning anything on, I should be able to charge this thing, and I should see some activity. So the light is green on the charger, and if everything is good, I think the charger should go to charging. Cool. All right, so I got a beep, and the charger went red, which is good. I think there's some sort of a light here. Oh, shit. Yes. Looks like the light is charging. Hey. I don't know if you can see that, but yeah, it's charging. I don't really want to turn it on yet, but it looks good. I mean, if we got to this point here, this thing is alive. So let's do this. I'm going to unplug it. Okay, so I took the battery off of the wheel after giving it a full charge. Everything is working on the wheel, so that's great. But I wanted to see how good a charge cycle does on this pack here. And I'm not sure if this thing does any balancing, but I let it charge for a bit, and then it finally shut off at full bars. So I took it apart again, and I can see that, you know, total voltage here 81.5, which means I'm hoping each cell should be over 4 volts, right? So starting from B0, so I see 4.13, 4.12, 4.12, 4.12. It's hard to get the thing here. Thanks. Right. Hard to check. Okay, let's just check every 2 then. 8.24, 8.26, so 7.98. That one's a little low. So if we were to check this and this, what's this one here? This one's 12. 36, oops. Hard to see this one here. 4.09. 8.12. 8.06. 8.04. Okay, so in the beginning, the one 8.25. So in the beginning, so they're a little over 4. So we're in the 4 to 4.1 range, and around the middle, they're in the 4, close to the 4.1 range. These are closer to the 4. Anyways, this is all fairly balanced within, say, 10%, plus or minus 10%. So that's pretty good. Okay, so next let's put this on the load testing machine, and let's see if we can drain it all the way to, say, 3 volts per cell, and then we'll check balance again, and then do another charge up. Let's see. Okay, so we're setting this battery pack on the test bench. I'm using my Fluke meter for an amp meter to get some accurate ratings. Then we use the test bench. We're going to try draw around 2 amps. I just tested it with like a 5% duty cycle. Looks like it's around 2.4 amps. So we're going to try to draw a little over 1C at 2.4 amps. Right, 1C on a lithium battery is whatever the rating is. So these ones are 2.2, so it's a little bit over, but that's still okay. So basically, I'm expecting to draw this load for an hour, and I'm not really expecting the BMS to kick in because it should still be above 3. So I think my regulator is going to get a little hot, but hey, let's see how it goes. All right, so let's begin the test. Let's see, down here, and start test. There we go. Okay, so let's let this thing draw some current for an hour and see how it goes. Alright, so had to shut it off. The equipment was just getting way too hot. But anyways, what we did measure is, let me see here, we went to 36 minutes at 2.4 amps. So that was half of the capacity that I was expecting. And then after remeasuring some of these guys here, you know, I'm looking at some really good balanced numbers. So all these, so as you can see here, 3.5 volts. So I measured all of these. These are all 3.5 volts, which means that these batteries are all balanced. So on the discharge, it went about half the capacity, and 36 minutes, which means that it has half more capacity in there. So these things are absolutely to spec. In fact, this is about 25% even more capacity than it when it came from the factory. So excellent, excellent batteries. And clearly the trick here was making sure, obviously, good quality batteries, measure them all, figure out what the resistance is, make sure that they all plus or minus a small degree within each other, and especially in a configuration like this, which is 20 in series and 1 in parallel, where every battery counts. So you can't have a weak battery here, or else this whole pack is toast. If it was 2 deep or 4 deep or whatever, you'd have a little bit more slack. But there's absolutely no slack here, so it's critical to have good batteries on this battery pack. So I'm 100% confident that this thing can go the distance. Excellent battery pack. All right, here we are back up and running. Everything's all buttoned up and everything works. So let's just power this guy up. There we go. All right. Takes a second. All right. So as you can see, self-balancing. Table's leaning a little bit, but if you kind of move it a little bit that way and try to tip it that way, you can see it follows you pretty good. I think you could even just kind of use it like a carry-on. Pretty cool, man. So batteries at the low bar, even though there's 50% left in it. So this wheel definitely monitors the low battery. So it doesn't let the BMS get as low as it possibly can. So, which means that it even uses less than the full amount of capacity of the battery. But anyways, that's how it works. So I think this one, so they all have different options. I think this one has a light. I think if you go the other way, it's the light. There it is. Yeah, light goes on. Some of them have a reverse light as well. This one doesn't have it, but it does have the MP3 player, which is cool. So, and I think that turns it off. And if you turn the whole thing off, there you go. And then it sits there. Cool. Successful battery repair.